Morning everyone, hope everyone's enjoyed their coffees. Please ignore me if I'm dancing around, I've hurt my back this morning, so good day to do it. So, I'm Peter Thistlethwaite. I'll be talking to you about UV light systems and automated fogging devices. And the changes over the last sort of 2 to 3 years as it's significantly changed what testing you are required to have for regulation on the market. First, a little about myself. I work for MSL Solution Providers. We're an independent testing lab, but I've got 8 years as microbiologist in disinfectants. I'm a representative at BSI, and I work with developing new methods in this field and all liquid disinfectants as well. So, automated fogging and UV disinfection, why do we do it? Whole room disinfection procedures like these provide a complete clean of the room in the shortest period of time with the lowest amount of human error. However, these methods have moved on from what testing was required pre-2020 into a sort of new series of requirements going forward, which will be required for BPR and for submission of dossiers and things going forward. So, automated airborne disinfection. It's the most common method with fogging or misting of liquid disinfectants. Most common actives are hydrogen peroxide vapor, peracetic acid, glutaraldehyde, formaldehyde, and recently we've seen an increase in quat salts or quaternary ammonium compounds. Previously, these machines using airborne fogging of liquid products had to meet AFNOR's NFT 72281. It's not those kind of NFTs. Products had to previously meet this up until 2020 when this standard was released. The new one is EN 17272. This was created in conjunction with manufacturers of both liquid products and the machines themselves, as well as micro labs up and down the UK. This was headed by a company called Bioquell that I'm sure some people in this room are aware of. This is now the required standard as of May 2020. However, a lot of companies haven't heard about it because we were all busy with other things at the time. They're both comprehensive methods and they offer claims against bacteria, yeast, mold, spores, and viruses. But if the claims are the same, why do I need to retest my product now against this EN method when I have the old NFT method? The new method offers a wider range of facility sizes. However, this is specified by the lab and what they can offer wherever you get this tested. And it offers both a small and large enclosure testing for things like Class 2 safety cabinets where you are using fogging to disinfect those cabinets, or if you're doing it in line on factory lines and things like that, all the way up to large room, warehouses, hatcheries in the veterinary field. Each of these areas now has its own specific bacterial requirement and its own specific soil levels dictated by its area of use, whether that is medical, domestic, or veterinary. And the biggest change is that EN 17272 has brought in what is now called a distribution test. This is a completely new part of the method. So the distribution test ensures that your fogging machine is able to distribute that liquid product to all areas of the room that it is in use. That seems something quite obvious for a fogging device to be able to do, but it was not checked in the NFT method. So if a product has been tested for efficacy, it does not necessarily mean it meets the distribution requirements. How a distribution test works is that there are 4 stands placed in 4 corners of the room holding 8 inoculated surfaces. These are both in front of the machine and behind the machine. The product must be able to achieve a 5-log reduction on all 8 of these coupons when they are shadowed from the device. This is what this looks like. My picture seems to have enlarged somewhat in the transfer over. But the stands stand in all 4 areas of the test room that you're using. This is the same in the small and the large enclosures. And your product must be able to get product to a shadowed area And this is something that's completely new to these methods. This is in comparison to the efficacy testing, where 3 coupons are placed away from, facing away from your device, but they are directly in front of it. So if your fogger or mister launches the product forward, it is more likely to pass efficacy testing than it is distribution testing. When it comes to things like hydrogen peroxide vapor, where we see a full room fog compared to something like a quat, where it is launched forward by peristaltic pumps, there is now a massive issue with this distribution test with these types of machines. So what does this mean for these test devices? Just because you've passed efficacy does not guarantee a positive outcome on distribution. This additional requirement ensures that a device is truly fit for its purpose in the area of use. This is something that's peace of mind for end users, but also it understands that the manufacturer will have extra R&D requirements here. It's something that the method is clearly wrote in to improve upon the old French method. However, it's going to mean quite a lot of machines may have to leave the market because they now no longer meet the requirements of test standards. Now this has been released in 2020, when do you have to be accredited to it? And the answer is really now. This was released in May 2020 and it's been on the market for 2 years. So fogging devices should have this test method if you're purchasing them. This is being added to the ECHA documents for BPR and will become a key claim for product families if you are selling for this type of use. And going forward, any member nation can ask for this, even if your active has already been submitted when it comes up for review process. So that's airborne fogging with liquid products. Next, we'll talk about UV room disinfection and what's changed there. So UV room disinfection, possibly the second most common whole room disinfection system commonly used in hospitals. It's been used for over 140 years. Up until 2022, there was no unified test method for how to certify these as the disinfectant properties of these machines. We know they work due to white papers, research studies, but there was no harmonized way for labs to show how 2 different devices compare. BSI saw this issue when developing the fogging device method, so has therefore tried to fill this gap as best we can as a standards body. So the test method sets a minimum requirement and a basic test layout similar to that of the airborne fogging devices. And this is how that test looks. So if you have your standing UV light system, you have your inoculated surfaces on a table or flat surface perpendicular to your light source. It adds a level of shadowing, but is still possible for UV light systems. The distance from the emitter to those surfaces is set by the manufacturer, but that now has to be stated in their usage. So if you're telling someone this works, you have to tell them how far away and how long it needs to be exposed to that light to pass this method. There is no distribution part of this test because, as we all know, light distributes evenly. And then there's a small enclosure method that again is slightly different. This works for things like Class 2 safety cabinets that have UV bulbs installed, and for pass-through manufacturing sterility when it comes to things like medical devices or food production. In this case, the surfaces face directly to the light source, as that is a direct exposure in the purpose of that disinfection. It is no longer acceptable to claim efficacy on surfaces based on swab testing, biological indicators, or light detectors. This has been standard practice for many years in the UV market. I've got so much light exposed in this area, therefore C. diff is dead. You have to now prove that with this method, with a log reduction suitable as dictated by the standard. You have to detail in all your literature the distance the machine should not exceed to be effective, and the minimum time frame that that exposure needs to take place. You must show log reductions and criteria for each method, for each organism. There are set log reductions that require. Bacteria is 5 log, spores are 4 log, viruses have their own. What this means, sorry. However, these methods aren't comprehensive, and there are still devices that outstand from these standards themselves. Handheld devices are not covered by either method. In the case of fogging and misting devices, they are treated as trigger sprays by the European Chemical Association. So handheld devices still treated like a trigger spray product. UV devices that are handheld aren't covered by these methods at all. So you may still be required to show efficacy data. That becomes more difficult, and that's working with labs to design a method around this BSEN 8628-2022. Liquid products also are the key design for fogging methods, and they are not designed for the purpose of things like ozone, which we're seeing an increase in usage in many different industries, including warehouse maintenance, pharmaceutical production, even hotels like this. And a key thing for these methods now is that if you change your device or if you change your liquid, a full retest will be required for dossier submission. So if your machine can no longer be provided by a manufacturer somewhere around the world, and you need a new machine brought in, your test method certificates don't stand. And some organisms, the specific claims, i.e. coronavirus, which we've all probably seen test results for over the last few years, they aren't specifically dictated in this method, with the issue of drying in this method, where you have to dry an organism to a surface. They don't survive, so therefore they can't be tested. So some specific claims may leave the market going forward. Now this is a shorter talk, so I'm going to open the floor to questions, but I'm going to allow sort of any questions on liquid disinfectants, wipes, as well as this as well.
Thank you, Peter. That was short, but yeah. Peter had warned me that he'll have a lot of questions. Peter, do you want a chair to sit on?
I'm all right, but yeah, my back is good.
Okay. Peter has a slip disc or something, so treat him gently with your questions. He did say and ask for a lot of questions rather than a lot of presentation. Can I just start, Peter? I have some history and background with VHP and fogging and formaldehyde gassing and so on. This new standard, I perhaps missed or didn't understand it fully, with EN 17272 and the publication of that, has that changed the climate for a manufacturer of a fogging device
yes.
in terms of what they have to provide and test and certify before they sell their device?
It hasn't changed what they have to do to sell their device, but any company now selling this as a disinfectant with a liquid product will need that standard, and that will include both the device and the liquid product in their dossier.
Right, because then I felt that there's an industry, that those are devices that are often purchased by a third-party contractor, a validation service provider, a decontamination company. They would then be under that EN 17272 providing data to show that it's efficacious within the space that it's going to be used in with the disinfectant type that is used within it.
That is correct, yeah. So if you are a manufacturer of a device, it may be worth taking a key active that you are already using in the market and carrying out the distribution test alone to ensure that your product is at least doing that part of it before selling it on to third parties for their liquid to go into the machine. Then at least you have some data going out. You don't have to do a full test, but that distribution test will be key and may change how that machine works.
Okay, and if you'll allow me one last question. You talked about the 8 coupons that would be placed within the space of a particular organism, I expect.
It's Staphylococcus aureus is the individual organism. Yeah.
So with these 8 Staph aureus coupons, that is different. Is that a specifically different test to what companies would have done up until now?
That is specifically different to what was required according to the AFNOR standard that was previous for fogging devices. So that 8 coupons is the distribution test that was not done previously. How the efficacy test works is your coupons are just in front of your device, facing away from it. So this distribution test can place them at several meters away, completely behind your machine or emitter.
I imagine, and maybe when we open questions up to the floor, there's some experience of fogging, gaseous disinfection, and how those have been proven or validated in different clean room scenarios. I would expect that people are already using some kind of biological indicator and validating the use of a fumigation process. But be interested to see what comes out now in the question and answer and discussion. So let me run around with microphones. I'll come back to you. Hang on. If you would introduce yourself, who you are and where you're from, please.
Jan Matler from Nielsen from Denmark. A question about fogging showers, the new standards there. If you need to make a specification for entrepreneurs to install one, can we lean us against the standard, or do you need to make a lot of extra specifications of what's needed for making a fogging shower safe? We are talking about fogging showers between high insulation rooms and the, say, kind of outside of this contaminated area.
I'm sorry, I can't quite hear.
Can you repeat again a little? So this relates to fogging showers.
Is it better now?
Yes, it's a little better, yeah.
Okay, it's regarding fogging showers, which should be the barrier between a high insulation suites for, say, COVID or worse, say, and to the outside. So we need to pass through the fogging shower to be decontaminated.
So those fogging showers, the walk-through systems, this
Yes.
is like gateways, yes?
Yeah.
They would class as a small enclosure device where you could put coupons essentially strung between the areas of the gate, and that would be perfectly suitable for that type of device. Obviously, with it being outside in its general use, that does lead to difficulties with lab testing, but as the standard is only created for use in a lab, so that's all you'd have to show. With it being outside, it would just be a matter of, you can do it in principle with a phase 3 field trial, but that may not be a requirement for government structure when submitting a BPR device. But I would recommend something like a small enclosure test, where you do the distribution between the areas of the gate.
Are you a manufacturer of those showers,
I'm
or are you
consulting engineer, so we need to make a prescription.
Interest on the UVC side. The microorganisms, is there any specified microorganisms then within the new standard? Because currently there hasn't been much, and I've used EN 13697.
So it's similar to 13697. So there are 3 areas of use, that is medical, domestic industrial and veterinary, and each one of those has a set amount of bacteria that you have to meet the claim for. So with medical, it's E. coli, staph, Enterococcus heri and Pseudomonas. For domestic, it introduces a different one instead of Pseudomonas, and for veterinary, it puts Proteus in there instead of Pseudomonas. So there's just 4 bacteria that are your minimum requirement, and then if you are doing spores, yeast and mold, viruses, they are all additional organisms, additional claims, and you can choose from the standard which ones you want to do.
So they're not naturally going to the hardest to kill, so which is currently would be the funguses, such as
They're not a
Aspergillus.
specific requirement. The minimum requirement is just a bacteria and yeast.
So is that a change for you? Is that your perspective that that's...
EN 13697 includes bacillus spore as well.
Again, with 3697 though, for liquid products, Aspergillus is only an additional requirement according to ECHA. So it's the same principle here. You do a bacteria and yeast, and then if you want to make a fungal claim, you would do Aspergillus as your fungus claim.
Is this a competing standard or a standard that's being superseded by...
It's the first standard.
This is the first and only.
We kind of cobbled together a standard of our own to try and test our own machines with the
Right.
3697 because there wasn't currently anything really used.
And EN 13697 is still a live document still applicable?
It's a live document for liquid disinfectants.
I understand. All right, okay. Thank you. Any more questions from the floor? Either on UV or liquid or gas? Keith.
Hi, Peter. I'm just curious as to whether you expect, with the introduction of these standards, sort of products to disappear from the market, or be withdrawn as a result of this, and
yes.
what the impact is then on the industry as a whole.
I do expect quite a lot of machines to leave the market. We have tested in the last 6 months to a year several UV devices and fogging devices to both of these methods, and we're finding companies that had confidence and had been placed on the market for many years with, especially with the UV device, they then were not able to pass this standard. The reason being the log reduction requirements. That was initially set by manufacturers, as you said. There was no standard. It was manufacturers just set their own requirement for log reduction. Now you must meet a 5 log reduction for bacteria. You must have a 3 or 4 log reduction for spores, for mold, for viruses, if you want to make those claims. And we're finding that UV devices based off that are using light exposure from white paper studies that says X amount of energy over this much time, C. diff's gone. We're finding that's not the case here. With the introduction of things like interfering substances, which in some of these cases is bovine serum albumin, but in other cases is blood for the medical area, the products don't work almost at all, again with some interfering substance there. For clean rooms it's different. You can use no interfering substance when it comes to clean room use. But if you go into a hospital ward, you'll be required to use medical interfering substance, and that has a significant impact on the performance of a UV device.
Peter, is that time constrained or time related? So to Keith's question of will products not perform and have to be removed, is the expectation of a 5 log reduction over a certain time the constraint, or can it just remain there for longer?
You can expose the light for as long as you want with this test method. You could put 24 hours on there, but then it's practical use within your industry. So if you've got a company that says we only have a half an hour cleaning time per day, we'll shut the line for half an hour, you can move your machines in for that long. Yeah. If you can't do anything in half an hour, which we're seeing as a common issue, a lot of companies come to us, I've got half an hour, should do everything including C. diff. We're finding that's not the case.
Yeah, so time may be the constraint rather than how efficacious it is. Okay, thanks Keith. Would anybody else like to raise a... That's okay.
So literally just following on about the interfering substances there, so for the clean room standard one, and use the bovine one there, is that as the clean or the dirt, because there's 2 levels, isn't there?
So it's your specification. So you can do low level or high level interfering substance. There are requirements for each area of use, so medical, domestic or veterinary. Domestic industrial has several within itself. So if it's in milk production, pharmaceutical production, there are specific requirements there. Cosmetic production has their own. If it is a clean room facility, and the assumption is the surface has no interfering substance on it, then you can use no interfering substance in a test method because that is the intended use. But if that device is then being used in other areas, like hospital wards, then you must use the interfering substance for that area as well in the testing. And that will require a test without interfering substance and a test with the interfering substance. And this is where things do get very complicated with all of this disinfectant testing. All right.
There you go.
Kimberly Snell from Zumtobel Group. I had a question specifically about the UV for the BS8628. Is this just with relation to UV machines that are put into the room and left, or is it also overhead UV lighting methods?
Currently, it is only for automated devices, something that is placed into a room, left to run, and no one is in the site itself. Handheld devices aren't technically covered by this standard. However, if you are making efficacy claims, it may be requested of you anyway. National bodies see a standard and they will apply it to your product, even if it doesn't technically apply in its own. So a handheld device, I would recommend something like the small enclosure, where we would hold it in a fixed position directly facing an inoculated surface. And if you can do that in a handheld way, that should be enough to cover you when it comes to BPR, or well, it doesn't quite apply for UV devices, but for government regulation, that would be probably enough.
And just a general question about kind of experience and also opinions. Do you have any experiences or opinions about, from UV lighting point of view, what is better? Is it better to have a handheld? Is it better to have a machine in the room? Is it better to use overhead or an integration of multiple methods?
We find the standing units to be better, UVC, high energy, but with longer exposure times that are currently claimed on the market. Handheld devices don't tend to give out enough light, and people don't tend to put them in a place for long enough. Passing over a surface quickly doesn't get enough log reduction now for this test method. And inbuilt ones in water systems, that's a different testing altogether. That would be water sampling compared to your handheld devices and your room integration.
Thank you.
So new to me, but is this BS8628? Is that right? Is that as a new standard published in 2022?
So that was published in April, and that will now be filtering out to government bodies. It takes time with any method to be picked up by regulators, but as soon as one machine tends to be submitted with it, it will then become what is asked for each time. And now it's published by BSI, it will be the UK's requirement at a minimum, but likely this will move across Europe as well.
Okay, so there is no legislation currently in the European Union, so SEN hasn't published or done any work on this.
It's been up to manufacturers at this point to provide their own efficacy data in any way that they see fit, whether that is an in-house method, a lab design method, or even just biological indicators and light exposure based off a white paper. This, because it harmonises that testing, is likely to be picked up across the whole of Europe, if not further afield.
And currently in Europe, are there any other national standards that are similar?
There are not, no.
There are none?
There are no methods for UV disinfection
Okay.
efficacy.
So this sounds like a game changer type of document. The British standard, the BSI, has taken a step forward that no other countries have yet standardised.
I mean, this was designed with manufacturers themselves of the tower devices and of small cube devices and class 2 safety cabinet devices, so it does work. It does provide steady results, so you can do this test 3 times, get the same result every time. However, it is hard for devices, especially with the shadowed perpendicular surfaces for tower UV systems.
Yeah. So with the BSI hat on, then please go to your BSI shop and purchase the new standard and begin its implementation.
After this, I'll set myself up in the lobby outside. If people want to talk about it in more detail, I have a copy of the standard with me on my laptop. We can go through that together if anyone's interested in doing that specifically.
There's an offer. You'll find Peter on a comfortable chair in the lobby afterwards.
Something to rest my back.
Okay. Any final questions? Okay. We'll move on. Thank you, Peter.
Thank you very much.
Really appreciate it.